Hey guys, in today's video we will be using YouTube to gather some alternative data for our financial analysis and hopefully use it as a way to gain an edge or gain some alpha in the market. No guarantees, but I think this is a really useful way of thinking outside of the box and gathering useful data from rich media sources like YouTube. We're going to be using the YouTube API, which is for developers, and everything that you can see in this video is public and totally legit, right? We're not doing anything crazy here. We're just going through a bunch of videos, extracting some information from those videos, saving it, and then using that as a way to do some more research about the financial tools that we're looking at. So let's jump into my computer and get started.
This is a pretty cool way of gaining some alternative data, and it's pretty legit. We're going to be exploring the YouTube API for developers. All you need to do is come over to YouTube API, and it'll show you a lot of stuff that you can do for it, give you some code samples. It's really useful documentation, and there's a lot of really cool things you can do with it, whether you're developing a new application or whether you're trying to search for particular content. In our case, we'll be using it as a method to gain a sentiment analysis on the market. First thing you'll need to do is install some stuff. So we're going to need PyTube, which is not affiliated with YouTube, but it's a Python package that will help us get the channel IDs for specific channels that we need. And then we'll also need transformers because when we perform the sentiment analysis, we're going to be pulling from HuggingFace. And that is it. The next thing you need to do is import the usual suspects like pandas, matplotlib. We're also going to be doing requests because when we call that API, it's going to come in as a JSON. So we're just going to request from that API URL. And another cool thing that YouTube is, or not YouTube, excuse me, another cool thing that Google Colab has integrated into one of the features that it's integrated is this key user data get. So you can store your API keys over here, and that way I can show you what we're doing, and I don't actually have to show my actual API key. So like I said, you're going to need to go over to developers.google.com/YouTube and go through their guide to get your API key, and you'll need that to call the API. So first thing we need to do is get our channel data, our channel IDs. I've just created a little function here that will use PyTube to get the channel ID. And we just make a YouTube instance and call the channel ID, and we return that channel ID. So if you just go to YouTube and get a bunch of videos from different channels that you want, you can use this on any video under that channel. So it's pretty cool. I just went out and got Bloomberg, Yahoo Finance, and CNBC. There's definitely a lot more that we could do here. If there's like a particular person that you were interested in who made videos on YouTube that had some coding experience and shared their sort of strategies online about the market, then you could just do their channel, etc. But really, the way this function works is it uses any video under that channel to get the ID. I just put that in a list and we for loop through it, and then I put all the channel IDs into one list, and you can see that these are the channel IDs. So you do need PyTube to get that channel ID because otherwise you'd have to do a couple of different API calls. And the reason it's just easier to do it this way is because when you go get the channel data that you're looking for, you need the channel ID to call that specific channel, right? So the idea here is that we want specific data from Bloomberg, CNBC, and Yahoo Finance. Specifically, what we're looking for is the time it was published, the title, the description of the video, and the name of the channel. And then we're going to put that all into we're going to put all that information in a dictionary, create it a data frame out of it and return that data frame for each video, or for each channel, I should say. So this is the actual API up here. You can see it's Google API, YouTube, plug in our key here, our ID there, and if we scroll over, it won't let me scroll over for some reason. If we scroll over, you can see that the results are 25. You could just easily change this function by putting results here, put in an integer, and then that would call whatever you put over here at the end. This instance, I'm just going to do 25 videos for each channel. So now I've just I've set the variables of our channels here, called the function, and I'm putting in each one of our channels from the list, 0, 1, 2, and if you recall, 0, 1, 2, the IDs, right? And my key as well, and then it goes through this whole function here and returns a data frame for each. So each of these are a data frame. I concatenate all of those data frames into one and reset the index so that it's all good to go. And if we take a sample of it, you can see here that we have the publish date, the title for some of the videos under each channel, the description of the videos, and then where it came from, so which channel it actually came from. So you can see a few here. There's no Yahoo in this sample, but I can tell you that there is some Yahoo Finance as well. So let's dive into this a little bit deeper. If we just call the API and we say, hey, let's just call that first video channel ID and let's get 25 results, and then we call it like any other API URL where we request the data in a JSON format, and then we just take a look at the data, you'll see it shows this very large JSON file with tons of information here. And I went through in creating the, basically I went through here when creating this function and I said, all I really am interested in are these 4 things here. But the JSON file provides a lot more, like thumbnail information, the broadcast content, which is none in this instance. We have the publish time. We have the page info, so the total results and results per page. We have the region code, which is pretty interesting. So if you wanted more info, you could totally do that. But in my case, since we're doing sentiment analysis, I'm really only interested in the description and the title for each video to see what the sentiment is of that channel given a specific time, right? Now, at the moment, I'm just pulling the most recent 25 results in each channel. You could continue to specify here in the API to pull from a certain specific kind of date if you're interested on a particular day, for instance. But in this case, we're just doing the first 25 results that come up. And at the time that I pulled all this data, that was 11:10. Cool. So you get this big long JSON, and we just put a function to go through this and only extract the information that we're interested in: channel ID, description, title, etc., etc. Cool. You can see it goes through 25 times, so you get a big long list here. So now it's time to actually perform the sentiment analysis on our YouTube titles and description. Very cool. So we're going to load a text classification model called Stilbert Fine-Tuned Financial News Sentiment Analysis. So MRM 8488 went through and fine-tuned I'm guessing a BERT model on financial news analysis. So we're just going to use the pipeline function that HuggingFace provides and go ahead and load that. Now, we then create in our data frame 2 extra columns called sentiment label and sentiment score. That's because when you run the pipeline, what you get is basically a dictionary of the sentiment label and the sentiment score, and I want to separate those out so that they're each attached to the data frame. It's a little bit hard to explain, but we just go through each row in the data frame and the results that we're going to get are uh, the values for the title and description. We run the analysis on it, and then when we get the results, we look at the first result, take the label, and attach that to the column in our data frame called sentiment label, and same thing for our score. So we should end up with something that looks like this, which is our original data frame with just these 4 columns plus the sentiment label and the sentiment score. So if we take a sample of our data frame, we'll have that on row 46, we had a neutral label, and the score of that was 99%. So in this instance, this video title description is a neutral sentiment on the market, and we're 99% confident of that. All of these are 99%, so there's some that are negative. Moody's cuts U.S. credit outlook to negative. That's pretty obvious. This should be a negative outlook title, right? 99%. The odds of a government shutdown are rising. That should be negative, and you can see that it is negative here. So, and then we have this one's a positive. So SAG after strike, a look at the lasting finance. SAG after came to a tentative agreement. Yeah, I would say that's positive news. And you can see that the model has rated it positive. So now we want to explore the results of all the sentiment that we've gotten on each channel. And so we just do a basic data analysis, and I went ahead and just put this into a pie chart. And you can see overall, the results are the same. Most of the videos and title description in our data frame are neutral. We have more on the positive side, more on the negative side. And we can do this for each channel. You can see CNBC is mostly neutral with a bit more positivity than negativity. Same thing with Bloomberg. They're a lot more negative than they are positive in this instance, but they're still mostly neutral. And we can even do it by date. So we have 3 dates here that the videos are spread over, and you can see that it's still mostly neutral on each day, with a whole bunch of videos being neutral on the 11/10 date. I'm guessing that's just because there's more videos in this date than there are in these ends. But you can see there's some positive and how it's broken up like that on each day. Now, definitely some improvements that we can make to this is grab videos between a certain start and end date. I think that would be really useful because then you could compare the sentiment of the to the prices or other more popular data that you would use for financial analysis. We might want to find a model with a sentiment score instead of a confidence score. That way you can maybe calculate an index. So for instance, what this score here is saying is that it's 99, the model is 99.98% sure that this title and description is neutral. And then this title and description, it's 95% sure that it's a negative, right? So it's not saying it's not like on a scale between -1 and 1, 1 being positive, -1 being negative. It's just saying that it's 95% confident that this is a negative title and description, which is good because it gives you some sense of the model's confidence power, but you couldn't really quantitate the overall score of the data frame using this confidence score here. So that might be something that we could look into as well in the future. And like I said, you would need that if you wanted to create a sentiment index, where you could see like, okay, is sentiment a lagging or predicting? I forget the actual word for it, but is it a lagging indicator or is it a, you know, indicator that indicates a movement in the market? And then, yeah, of course, if you created that sentiment index, then you would obviously explore the relationship between that sentiment index and the market as a whole. So something I might try to do is add a sentiment, like go through all this and then add it to a finrl model. But I know you guys like finrl. I know the same guys over there at AI for Finance have built a GPT model or a GPT sort of work frame, or man, I'm all out of words today, but I would like to create a sentiment index using this method and then run it through a finrl model or do some more machine learning with that index combined with greater financial data as well. So I hope you guys enjoyed that. I think this is a really good way of thinking outside of the box and using public information that's out there to get some sort of alternative data and mix it in with your trading strategies and the way you might think about how the market behaves, right? Because if you think about it, Yahoo Finance has like millions of views, millions of subscribers, thousands of views every day. Same thing with Bloomberg and CNBC. Like people tend to watch those shows and make pricing decisions based on those shows. Anyway, thanks for watching, guys. I appreciate it, and I'll see you in the next video. Bye.